Okay, guys. So today we're gonna start a new chapter. It's kind of continuation of what we have seen it. It's again about the time value of the money, but it's more in detail and with a different approaches. And what I would like to just give the quick announcement again regarding the quizzes. So I don't know, did I tell you or not yesterday, but we have on 6th of June, it's holiday. So we were planning to have the midterm. So what I'm gonna do on 5th of June, I'll make the quiz. And 9th of June will be the midterm. So you'll have the time for studying for the midterm, okay? So again, 5th of June, you're gonna have the quiz. Then we will not meet. And this class should be going for makeup. I'll announce when I'll do this makeup too. And here on 9th of the June, we're gonna have the midterm one. Actually, and we have 12 and 13 of. I'm thinking not to make this second quiz, just to go with the second midterm only. I will think on that. I'll get back to you tomorrow, okay? Because we cannot have like so many quizzes in the midterms at the same time in the 1 week. This is the one issue. And the second issue that I'd like to tell you, if I didn't tell you yet, it's about the last week of the classes, which is end of the June, starting from 25th, 26th, and 27th, the last 3 days. I invited the practitioner. He will come and with a project share with you, and he will show you how to do certain things in the industry, and he will give you a small project. You will do it at home and you will submit it soon. So we'll have like in total, the final exam is like 25%, 15% will be the exam itself, 10% will be the project. So it will be mostly group-based project. So I want you to be involved in the project too. He's from the investment bank, so he's gonna share his experience and so on. Okay, now, any questions before I move? Okay, perfect. So in this chapter, we'll compute the future value of multiple cash flows. So far, we have been dealing with the single cash flows. Okay, we were given only one cash flow, and where we estimated future value and the present value. So at the same time, we will be determining the future value of annuity. Annuity, it's another measure of the cash flows that shows that the certain cash flows are repeated. Like same amount of the cash flow will be given throughout the same period of time. So that's called the annuity. And then we'll compute the present value of annuity too. Then we'll also adjust the annuity equation for present value and the future value annuity. And understand the concept of the perpetuity too. So we'll try to differentiate between the different types of loan repayments, like discount loan, interest-only loan, and amortized loans. So then we'll build and analyze the amortization schedule. Amortization schedules are used in the banking sector, mostly like when they provide the loans, like for mortgage loans, car financing loans, and they just kind of amortize the loan. We know that there is a depreciation, as you heard many times and you've seen it many times. When you buy a certain item, it's a subject to depreciation. It loses its value. When any company has got the asset, like tangible asset that you can touch, it's subject to depreciation. It's subject to lose its value. And the banking sector or the financial institution, they have their assets too, but not tangible. Most of their assets are intangible. They are all financial instrument based, like loans, securities, and so on. These loans that the bank, they have it, they are subject to amortization, okay? When you amortize it, you reduce the amount of the loan. The same thing with the asset. When you depreciate the asset, you reduce the amount of the asset, the tangible one. That's the main difference. So we will be calculating the time period and the interest rate for annuity, apply the time value of the money concept to evaluate the lottery cash flows. And of course, as a summary, we'll summarize the 10 essential points about the time value of the money. So with unequal periodical cash flows, so far we have seen like you're given one cash flow today, and what is the value of this cash flow in the future? Or you're given one cash flow in the future, what is the value of this future cash flow today? But imagine you have several years and you have unequal cash flows, like not one cash flow, but 5, 6, but all of them are different. Like in year 1 is 300, in year 2 is 500, in year 3 it's 400, and it goes like this, like changing. So then we need to actually use same techniques to calculate the future value or the present value, but with the individual approaches, like individually get each cash flow, take the future value, and then calculate. And at the end of the day, you're going to sum them up, you calculate a certain future value of the cash flow. Imagine like in year 0, you deposit $2,000. In year 1, you deposit 3,000. In year 2, you deposit 4,000. And in year 3, you deposit 5,000. What is the future value of this cash flow? Having in mind that the interest rate of this bank that offers as a depositing rate is 5%. So what do? Just you take the future value of each cash flow one by one, and then add them up. Like take the future value of this 2,000 in 3 years. Like what is the future value in 3 years of this investments? So what do? You get this $2,000, take to the future value to year 3. How many years? We can see 1, 2, and 3 years. Yeah. So you will raise to the power 3. Or if you would use the function like future value equal to like number of period 3, the interest rate is 5, and the present value is 2,000. Whatever you get, this result is like 2,350. Then $3,000 again, 2 years from this year, you raise it to the power 2, you calculate the future value of this 3,000 and 4,000. And the last cash flow in year 3, it's not changing because it's same cash flow. So what do you do at the last moment? You just add them up and you get the total future value of this cash flows. That's what we calculate. And it's not a new thing. It's just show you the approach how you should deal with the unequal cash flows in a certain project. Okay. Let's say Jim deposit 3,000 today into the account that pays 10% per year and follows up with the 3 more deposits at the end of each year of the next 3 years. Each subsequent deposit is 2,000 higher than the previous one. How much money will Jim have accumulated in his account by the end of the 3rd year? 3 years, okay? Basically, if you go just check the Excel, let's go. Here we go. So we have 0, 1, 2, 3, 4 years, okay? It says that, look again, the question, Jim deposits $3,000 today, and the next, so there are 3 years actually, okay, 3 years. So 3,000 here, but the condition is that with the 3 more deposit at the end of each next 3 years, each subsequent deposit is 2,000 higher. So it means that here you're gonna have 5,000, here you're gonna have 7,000, here you're gonna have 9,000. And you're asked the question, how much money will Jim have accumulated in the account by the end of the 3 years? So you need to calculate how much money you're gonna have it in total. So basically, you need to calculate the future value of this cash flows. They're unequal, but you need to treat them separately, okay? So basically, if I do it like this, future value, open the bracket, rate is 10%. Number of period is for this, how many years I should take it into account? 3 years, yeah? And PMT, I don't have it. And present value, 3,000, but I should put this a negative sign and close the bracket. So this 3,000 in 3 years will be this much. And I just pull it down. So here I'll change the number of periods will be 2. Here I'll change the number of periods will be 1. And here my number of periods will be 0. Okay. So that's it. The future value we calculated. What do you do then? You just add them up and you come up as total value that is accumulated at the end of the 3 years. Just sum them up. That's what we have. Okay. Just put it in the formula. Text. Okay. Any question? Okay. Okay. And this what it's like when the cash flows are different. There could be cases when the cash flows are repeated, like every time you deposit certain amount of the money for some reason, like from 0 to 1 to. But before repeating it, okay, before I'll just go with it. What if I put the cash flow like this? Again, how are you going to calculate? Calculate the total value, what will be in 3 years. What are you going to do? Just take the future value of each cash flow and add them up. You're going to get so in year 0, we don't have anything. We start the cash flow. We put the cash flow in year 1, yeah. Not from today, like from the next year. So basically, you're going to calculate again the future value. Rate is, again, let's make it 10%. Oops. Number of period from year 1 to 3 is how much? How many years? 2 years. PMT, we don't have it. And the present value is this. And we just put it down. This, I will change it to 1. And this, I will change it to 0. And I will add them up. It will give me 7,750. Okay. That's my future value. Imagine the project tells you that you will deposit each year 500 each year, but not 3, but like this, 300 years. Okay, each year you're going to be putting for 300 years. Yeah, just for 300 years, $500, and the discount rate is 10%. What will be the value at the end of the 300 years? So you can calculate the same approach, like if you're taking the future value, but it's going to take time. Yeah. As we see the key points in here, the key points are the cash flows that we have in each year. They are same, no change, like repetitive, like they're exactly the same cash flow. We call them annuity. Okay, the cash flow when it repeats, it's called annuity. So there's a formula we use. Is just basically if you're going to calculate the future value, it's basically future value equal rate is 10%, number of period is 300, PMT. PMT in here means the cash flow that are repeated from year to year, the cash flows that are the same from year to year. Okay, that's what it means, the PMT. So that's why we have not touched this PMT before, because we didn't have such cases when the cash flows are repeated. We only had the case when it was just one single cash flow, or we had the case different multiple cash flow. But in this case, cash flows are repeated and we can select them as 500. Okay. Again, we close it. That's it. And then we will be able, we don't have any present value because we're calculating the future value. Present value, it's when you just use just one single cash flow. But in here, we just calculate the future value, annuity. Your cash flows are repeated. Okay. And I put just negative sign here before so that I don't have it negative. You see, I have negative sign here. In order to remove the negativeness, I just put the negative sign here. Okay. That's we call the PMT. You can do it as we did it like in the previous example, treat each cash flow separately or individually, calculate the future value of each cash flow, and then add the mark. That's what we have it. Or another formula, if you're going to use the scientific calculator, it's basically PMT, it's annuity multiplied by annuity factor. Here, we just multiply with this factor. Like 500 multiplied by 1 plus R, which is 10%, minus 1 over R, which is 10%. And then you're going to get exactly the same answer. But of course, this should be raised to the power 300. Okay, you can still calculate. Okay, when I was doing my bachelor program in finance, like we used to calculate using this formula. We did not have any financial calculators. We did not have any Excel. We used to do all the calculation based on this formulas. And plus we were given the tables where you used to have the annuity tables, which I forgot to show to you. Let me just share it with you. But you're not going to use it, okay? It's just for differentiation to know, like, there are some tables and you can use like this. Like these tables you are given, okay? For example, number of period is 20 years. You select 20 and the interest is 6%. You select 6. So you basically, here, basically this is the factor that you're going to be using to calculate your future value. You're multiplying the present value with this factor will give you the future value of the amount. And if it's annuity, it's here. Yeah. For example, in this example that we are given, like $2,000, 10 years, and 8% interest. Yeah. So basically, you can calculate using the Excel very easily. It's basically future value. Open the bracket. Rate is 10%, sorry, 8%. Number of period we set is 10. And PMT is 2000. So that's what we have at future value. Okay. Is it, yeah, 10 years? Did we get, yeah, 28. So that's what we use the formula. You can use the book as well, like this table, but you see 10 years here, but 6%. Unfortunately, we don't have 8%. That means that you should still refer. But there are more like comprehensive tables that calculate the interest up to 20%, but still, if the interest rate is not like absolute number, it's just with the decimal numbers, then it's going to be really challenging for you to use this table. So this table basically used to calculate. If the interest rate was 6%, like not 8, but 6%, okay, imagine just 6%, I would be able to use this table. So 10 years and 6%, so I will use this number, 13.18. Now come here. So this number I got from the table. So what I will do is basically 2000 multiplied by this number. And it gives you exactly the same answer. It might seem like very easy, but you will be stuck when the interest rate is not like absolute, like with the decimal numbers, like 6.7, 6.25%, 8.65%, and so on. And then you won't be able to go with this table. So just for you, for your information, how can we use this table? So we used to have these formulas to calculate and the tables to use it. Okay. So that's what we have it. Okay. And present value annuity. The story about the present value annuity is the same. Like the only thing we calculate the present value, stream of the cash flows again equally given, and we use this formula, or we use the formula in function and we use PV. Okay, just equal sign PV, and you can see that rate, number of periods, and PMT we are given. And that's fine. And example is given here. You're given future stream cash flows and you want to calculate what is the total value of these cash flows equal today. Let's say you're supposed to receive some income in the future, like in 5 years, and you want to see in total when you receive in 5 years, how much it will be equal today. What is the value, whether it's worth to go with it today. That will help you to calculate the present value. So John wants to make sure that he has saved up enough money prior to the year in which his daughter begins college. Based on the current estimates, if he figures out the college expenses will amount 40,000 per year for 4 years. So John would like to pay for his daughter money for the school, yeah? And he's expected that he will be paying 40,000 per year. Ignoring that there is no inflation, okay? And during the 4 years, of course, how much money John needs to have accumulated in account that earns 7% per year, just prior to the year that the daughter starts the college, basically. So the 40,000 years, so how much money he should have now in order to start paying 40,000 for the coming years, okay? He would like to pay the school fees, okay, let's say. You want to pay the school fees. Yeah. So he want to pay the school fees every year, 40,000. Okay. But to do that, he doesn't know how much money he should have it now in order to be able to pay every year 40,000, ignoring the case of inflation. So basically, you're going to calculate the present value of annuity. It's PV, rate is 7%, and number of period is 4, and PMT is 40,000. And I put the negative sign here. So he should have now $135,000, and he will be able to put like 40,000 every year. But the question in here is that another thing that I would like you to pay the attention is when the annuity stock is used, all the cash flows are at the end of the period. That's the point. When there is a cash flow, they're end of the period. Like means in ordinary annuity, we don't have any cash flows that starts in year 0. They always start at year 1. Just keep it in mind, okay? Not to get confused. Another thing that it's about the future value and the present value, it's another story. So in the exam, you will not be given directly, please calculate the future value annuity, or please calculate the future value. Your job is to find out whether it's a future value, whether it's annuity, and whether it's just single cash flow. Okay, you need to read the question carefully, you need to understand. Of course, to do that, you need to practice as much as possible. Now, I will solve another example here, okay? A cash flow stream, okay. Another issue, okay, we said that there's an ordinary annuity and the all cash flow starts at the end of the period, like starting from year 1. But there could be cases when the cash flow could start at the beginning of the period. Then that will be called not ordinary annuity, it will be called annuity G. Okay, we have ordinary annuity where it's end of the period. And we have annuity due, which is beginning of the period. So that's the main difference. So if the question tells you the cash flow starts at the beginning of the period, it's an annuity due. If the cash flow starts at the end of the period, it's an ordinary annuity. Ordinary, it's when the cash flow starts at the end of the period, like starting from year one. Beginning, it's basically this cash flows moves like this, will be like this. This is annuity due. And this is ordinary annuity. This is ordinary. And this is annuity due. That's the main difference. And when you're going to calculate the value of it, whether it's a present value or future value, you're going to be having different numbers. And of course, the formulas are different. For annuity due, the formulas is like this. For any ordinary annuity, you just multiply by 1 plus R. And present value of annuity due is always greater than the present value of ordinary annuity, and future value annuity due is greater than the result. Okay. So if you calculate the ordinary annuity due for that example that I give you, so you will see that this annuity due will be higher than the ordinary annuity in terms of the amount. Using the financial calculator, you just need to change the modes, like from ending to beginning or from beginning to ending. And in the spreadsheet, you use the following, like 0 for ordinary, or you don't use anything, it's automatically by default, it uses ordinary. Or if you want to specifically to use as annuity due, then you should specify the type to be S1. Example. For example, I want to calculate the future value annuity. I just basically future value. Rate is 10%, we said. Number of period, let's say 4, yeah? PMT is 4,000. And I close it. This is my ordinary annuity. The same thing I want to do here. Future value, rate is 10% again, number of period 4. Cash flow is, the PMT is 4,000, but here you need to specifically mention that it's due. You see the last here, the type? Here. No. Here, type. You put one more bracket. You skip the present value because we don't have its present value, and you put here type. Okay. You have the end of the period, you have the beginning of the period. So you should mention it's annuity due. Then you select 1. I close the bracket, and you can see that my cash flow is higher than ordinary annuity. That's the main difference between due and ordinary annuity. So in the question, if it's stated that the cash flows are at the beginning of the period, then you are talking about annuity due. If the cash flows are given in the timeline as at the end of the period, then you're going to be calculating ordinary annuity. Is that clear? So please don't make confusion when you'll be calculating. It's very important because the results that you're going to be getting, it's totally different. Okay. Now, I move further. So let's say that you're saving up for your retirement and decided to deposit $3,000 each year for the next 20 years into an account that which pays you rate of 8% per year. By how much will your accumulated nest egg vary if you make each of the 20 deposits at the beginning of the next year and starting right away rather than at the end of each next 20 years? So basically you need to calculate what? Annuity and ordinary annuity too, both, yeah? But future value or present value? Here's a good question, yeah? You don't know. Like, you need to understand like what you are calculating. How to differentiate? It's a present value you're asked to calculate or future value? So in the exam, you'll be given the similar questions like, you will not be told, guys, you are calculating now future value, calculate the future. No, you will not be told like this. You need to understand the question itself. Yeah, it's a future value. How did you get that? It's a future.
No.
Okay, and look at the question. It says like here, by how much money will you accumulate nest egg? Nest egg is like summation, okay, sum of in total. If you make each of the 20 deposits at the beginning of the starting right away, rather than at the end of each period of the next 20 years, like in the future. It specifically mentions that in the future, how much money you're gonna make it. So let's do it. So we have future ordinary and we have due. In ordinary, we're just gonna calculate the future value. Rate was 8%. Number of period is 20. PMT is 3,000, yeah? Present value, I don't have it. And this is 0. Or I don't put anything. It's by default ordinary. And of course, I need to put negative sign here. And future value here. Rate is 8%. Number of period 20. PMT 3,000. I put 1. Put the negative sign here. So which one is like profitable? Of course, due for you. Yeah. You would have selected the type of contract with a pension fund to go as due, because the due will give you more income. And perpetuity, it's a equal periodical cash flow stream that will never cease, means that will never end. Like it's unlimited period of time. You'll be receiving this amount of the money without any time concern. Okay, well, it's forever. That is called like perpetuity. It's basically to calculate the price of it, it's PMT over rate. But what does it mean, like receiving the money forever? Is there such a cases in the real world? Yes, there is. We call them as stocks, but it's not just stocks, it's a privileged stock or preferred stock. The preferred stock gives you the fixed amount of the dividends, but forever. You receive that dividend regardless of the company's financial position, regardless of the time. But of course, you will stop receiving when the company gets into bankrupt, when the company just dissolves, okay? Then you will be then you will stop receiving it. But apart from that, there is no time where you can receive the cash flows. And the example here, if you're considering the purchase of the console that pays you $60 per year forever, and the rate of interest you want to earn is 10% per year, how much money should you pay for that console? It's basically the PMT over the rate. Any questions about the ordinary annuity? So on your shoulders now, guys, you should be able to differentiate the difference between the future value and the present value, ordinary and due, single cash flow, and multiple cash flows. Okay, the question will be given. You don't know whether it's a annuity or it's a single cash flow. There will be such questions. The only way to differentiate the single cash flow from annuity tells you specifically the cash flow will be received every year, every period, each year, at the end of each period, like at the beginning of each period. Like it tells you specifically that the cash flows are there. Okay. So apart from that, we have 3 types of loan payments. First is discount loan, interest-only loan, and amortized loan. Discount loan is when the principal and interest is paid as a lump sum amount at the end of the period. Interest loan, it's a periodic interest only payments where the principal due at the end of the period. The principal is the amount, the main body of the loan, okay? That's what we call the principal amount. An amortized loan, it's equal periodical payments of the principal and interest every period. So in Kazakhstan, we have mostly amortized loans. Let's consider the example. Rosanne would like to borrow 40,000 for a period of 5 years, and the lender offers her the choice of 3 payment structures. Pay all of the interest, 10% per year, and lump sum at the end of the period of 5. Or pay the interest at the rate of 10% per year for years, and the final payment of the interest principal at the end of the year is 5th year. And the third choice or alternative, pay the 5 equal payments at the end of each year, including the interest and the principal. So, but in an equal amount. The first one we can see it's a discount. The second one is like interest only payment. And the third one is like amortized loan. Amortized is when the payments, interest, and the principal are equal for a certain period of time. So under which of the 3 options, Rosanna pay the least interest and why? Calculate the total amount of the payment and amount of the interest paid under each alternative. For example, since, let me do it in this way. We have discount, interest only, and amortized. Yeah. But 5 years. So you get your loan here, 40,000. And what was the interest rate? 10%. In a discount manner, if you get like $40,000 here, okay, then you have to pay here, basically the future value of it. Rate is 10%. Number of period is 5. And PMT, we don't have it. It's just one payment. So your total value is equal to this. So you get 40,000. After 5 years, you pay 64,000. That's the loan agreement in the first case. In the second case, it tells you pay interest only every year. Like you get 40,000 here. You get your 40,000 here, okay? But in here, you will be paying every year 10%. Every year. Yeah. And at the end, you'll have to pay the total principal too. 44,000. So in total, how much you're going to be paying? $44,000 plus 4,000 multiplied by 4, yeah? 60,000. That's what you're going to be paying in total. This. And in here, that's the interest-only loan. So if you just compare these 2 types of loans, you would be kind of suggesting to go with which type of loan? If you are given only 2 types of loan, discount and interest-only loan. Interest loan, you would suggest Rosanna to go with the interest-only loan because there she will pay less interest. With the amortized loan, where you will pay equal payments. When it's an equal payment, we call it what? Annuity, yeah? Annuity. So basically, we're going to be calculating the annual cash flows. It's PMT. Rate is 10%. Number of period is 5. And present value is 40,000. And we don't have the future value here. By the way, when it's about the loan, then we should calculate the present value. So sometimes you will be asked to calculate the PMT, calculate the total payment. There will be questions you will see. Then you have to calculate, you have to understand whether it's a present value or future value. If it's a loan, then it's definitely present value. So it means that every year you're going to be having this much. Sum it. Now, you're given three different types of loan: discount, interest-only loan, amortized loan. Which type of loans would you like to offer to her as the best alternative? Amortized, yeah, amortized is much, much cheaper. So Rosanna should go with amortized type of loan. Okay. That's what we got it, calculated, and gave the suggestion to them. Any questions? Is everything clear? Sure? Okay. Let's move on. Another thing that we would like to cover here, it's like amortization schedule. It's a tabular listing of the allocation of each loan payments toward interest and principal reduction. So it will help the borrowers and the lenders to figure out the payoff balance on outstanding loan. So first of all, we'll compute each equal periodic payments using the PMT function. Then we'll calculate the interest on unpaid balance at the end of each period. Then we'll subtract the PMT to reduce the loan balance by the remaining account. And then finally, we'll continue the process for each period until we get zero loan balance at the end of the period. Imagine they prepare the loan you are given a loan amortization schedule for amortized loan, given the example of 6 above, like 40,000, 10% number of years. Okay, let's do it. Here, 1, 2, 3, 4, 5. The beginning balance, BB, we call it, it's 40,000. That's what you start with, yeah? And we have total payment. I will call it like TP. Oh, let me just make it beginning balance. Total payment. So, and the issue in here in amortization schedule, the total payment should be fixed for all years. For all years, it will be fixed. Then we have interest paid. We have principal reduction. And we have ending balance. Now, for total payment, we need to use to calculate total payment the PMT function. Again, PMT function equal to interest rate is 10%, number of period is 5, and present value is 40,000. And I close the bracket. So that will be my total payment. Every year I have to pay this. This total payment includes interest paid and principal amount, both together. And every year it's going to be fixed. Okay, 5 years, I have the same total payment. My interest payment, it's basically interest on unpaid balance here, as it said. Calculate the interest on unpaid balance at the end of each period. Okay, so this is my unpaid balance, and I have to just get 10% Where is it? Of this 40,000. Okay. My principal reduction, it's like how much my principal amount of the total payment will be at that corresponding year. If my interest paid of this $10,000 is 4,000, then the principal reduction is the difference between the interest paid and the total payment. So total payment minus interest paid. That will be the amount that I'm paying. So both these two will be my total payment. And ending balance, it's basically beginning balance minus principal reduction. And my beginning balance of the second year, it is the ending balance of the first year. It's this. Interest paid of the second year, it's basically interest of unpaid balance of the beginning balance of the corresponding year. What I will do here, guys, I will just pull it down like this. Oh, let me don't do it. Like I will go one by one so that you can see. 10% multiplied by this. Again, my total payment minus interest paid will give me the principal reduction. My ending balance is basically beginning balance minus principal reduction. Again, beginning balance of the third year, it's an ending balance of second year. And interest paid, same, 10%. My principal reduction is total payment minus interest paid. My ending balance is basically this minus this. And beginning balance of the fourth year, it's the ending balance of the third year. My interest paid again 10%, multiplied by this. Principal reduction is the total payment minus interest paid. Ending balance is this minus principal reduction. And my beginning balance of the fifth year, it's the ending balance of the fourth year. Interest again, 10% of this. Here you go. So imagine if it's 10 years, then it doesn't mean that you have to calculate everything like one by one. If it's 20 years, when you get a loan, you get a loan for 25 years. If it's 7 years, if it's monthly, it means like 360 periods, okay? It doesn't mean that you have to calculate everything manually. So what you can do here, imagine you don't have this, you don't have this. So what you can do here, up to this moment, you just fill it, and then the rest you just pull it down. Pull down, and pull down. That's it. The important part is the first line, you should fill it correctly. If you fill the first line correctly, the rest you just pull down. And of course, put like second, like this line, you should do it, and this. The rest you can just pull it. Okay? And of course, this one should be same. That's what we call it, the amortization schedule. So you might be asked the question, please, what is the principal reduction in the year 4 in the exam? So you have to give me this number. This number should be given. You might be asked, what is the total interest paid? So you have to sum them up and tell me that 12,759 will be the interest paid. What is the interest paid in the year 3? If the loan conditions are this. So you need to create the amortization schedule and get the number and put the right answer there. Okay. I might ask you, please tell me what is the summation of the last 2 years of the interest. So you sum this up, give me the interest. Okay. That's what I expect from you. Any questions? And of course, we can calculate in here waiting time period, interest rates for annuities, using again like number of periods, PMT, using the present value, future value, and you can calculate the rate and the number of periods as we did it in those examples. Solve from the number of the annuities, number of periods, okay? Martha wants to save up like $100,000 as soon as possible so that she can use it as down payment for her dream house. She figures out she can easily set aside $8,000 per year and earn 8% annual on her deposit. How many years will Martha have to wait before she can buy the dream house? Question. Is it future? We understood that we need to calculate the number of periods. Yeah, it's definitely like we just put. We put here the number of periods in the exam here. You just type NPR. But the question in here, is it the present? Let's say the rate is 10%. So let's get the rate here. Rate is 8%. PMT is how much? 8,000. But is it present value or future value? Are you sure? Read the questions carefully. So it is future value, yeah? So it's in here, it doesn't mention specifically that it's a future value number of period. Again, you're the one who has to determine whether it's a future value or the present value. So this money, $100,000, you need to save up. It doesn't mean that you have it now. You need to have it in the future. So that's about the future value. So you're calculating the number of period of the future value. Sometimes you'll be asked to calculate the number of period of the present value. Okay. So we put 0 here and we put 100,000 here. And I get this now because I did not use minus sign. I should put it inside of the bracket. Either just put it here before the future value. Do I get the same, like 9 something? Yes, 9 years. So in the exam, you might have the problem when you forget to use the negative sign. Even if you use the financial calculator, it asks you to use this sign, minus sign too. In financial calculator, in Excel, you should not ignore it. You should use it. So use the negative sign here. Either put it before the future value or present value. Okay. Calculating, I'll come back to this question again. Okay, there's 10 important points about the time value of the money. So the amount of the money that can be used and added and subtracted only if they are at the same time. You cannot, when you calculate the time value of the money, you cannot subtract the cash flow from the second year, the cash flow from the third year. They should be in the same years. Either you bring the third year cash flow to the second or bring the second to the third year. And then you make the old calculations. That's the main principle. The timing and the amount of the cash flows are what matters. It is very helpful to lay out the timing and amount of the cash flow with a timeline. So never forget to put the timeline to get a real picture what you're trying to calculate. The present value of the calculation, discount of all future cash flow back to the current time. Future value calculation are basically cash flows at a single point in time in the future. Annuity is the series of equal payments and regular intervals across the time. The time value of the money equation has 4 variables, but only one basic equation. And so you must know 3 or 4 variables before you can solve the missing unknown variables. If there are 2 missing, you cannot calculate either it's a future or present value. That's the thing that you should keep it in mind. And there are three basic methods to solve the unknown value of the variables. It's using the equation, calculating the answer, using the time value of money equation, keys on the calculator, and using the financial functions from the spreadsheet. And we will be using mostly 99% the third one. There are three basic ways to repay the loan: discount loans, interest-only loans, and amortized loans. So despite all seemingly accurate answers from the time value of the money equation, in many situations, not all of the important data can be classified into variables of the present time. So time, interest rate, and the payment of the future value, they should be taken into account. So that's all about this chapter. Do you have any questions? Anything you'd like to ask? Anything you want me to clarify before I will let you to do one activity? Okay. If everything is good, then please do the following activity and go home. I have, let's say, I'm removing this. This. Let's say your loan is 60,000. The interest rate is 12%. 5 years. So fill this amortization schedule, submit it as activity number 4, and we are done.